You told it in the second message to stop using bullet points. 10 replies later, bullet points. So here's the answer before the mechanism turns up. It didn't forget because it never remembered in the first place. Nothing inside a language model carries over from one message to the next. Every single turn, your whole conversation gets shipped back through the model from the beginning, and it reads the lot fresh, the way a locum doctor reads a chart. When an instruction goes missing, one of two things happened. Either the transcript grew past the limit and your line fell off the edge, or your line is still sitting right there in the input and the model failed to use it. That second failure has been measured precisely by a team from Stanford, Berkeley, and the startup Samaya AI, led by Nelson Liu, in work published in the journal Transactions of the Association for Computational Linguistics in 2024. Answering questions across 20 documents, GPT-3.5 Turbo scored 75.8% when the answer sat in the first document. Same question, same documents, answer shifted to the middle, 53.8. And in the worst case they recorded, handing the model the documents left it doing worse than handing it nothing at all, which scored 56.1. Start with the unit, because the rest follows from it. Models don't read words. They read tokens, the word-sized fragments a tokenizer chops text into, where a common word is usually one token and a rare one gets broken into pieces. Every token the model can see at once lives in a single buffer called the context window. Anthropic's developer documentation calls that buffer, in as many words, a working memory for the model. Look at what's crammed in there. The system prompt. The whole conversation so far. The document you pasted, the output of any tool it called, the web page it fetched, and the answer it's halfway through writing. All of it competes for one fixed space, counted in tokens. That space has grown fast, and 1 million tokens is now an ordinary figure on a spec sheet, which sounds like room to spare until you watch what happens on the way up. That buffer isn't memory in any ordinary sense, because it doesn't survive the turn. The docs spell the loop out plainly. On each turn, the input contains all previous conversation history plus the current user message. Your chat app is the thing holding that transcript. The app resends it. The model reads it, writes a few hundred tokens, retains nothing. Its weights don't change while you're talking to it. Open a new conversation, and the only reason it knows your name is that a piece of software outside the model saved that text, then pasted it back in before you typed a word. So why not make the window enormous and stop worrying? Cost first, and it's an unfriendly shape of cost. The mechanism that lets these models relate one token to every other token is called attention, and it comes from a 2017 paper out of Google by Ashish Vaswani and 7 co-authors, under a title that has aged into a joke. Attention is all you need. Table 1 of that paper prints the bill. Complexity per layer for self-attention is n squared times d, where n is how many tokens you've handed it. Anthropic's engineering team put the same fact without the notation in September 2025. N tokens produce n squared pairwise relationships. Double the conversation, quadruple the work. Make it 10 times longer, and you've made it 100 times more expensive to read. But money is the easy problem. The hard one is that a bigger window doesn't reliably behave like a better window. That same engineering post describes an attention budget, a finite pool the model draws down as it reads, with every new token spending a little of it. Their account of the lost precision isn't arithmetic at all. Models learn their attention patterns from training data, and in training data short sequences vastly outnumber long ones, so the enormous context is the case the model has practiced least. Liu's team gave the failure a name that stuck. Lost in the middle. Chart accuracy against where in the input the useful fact was hiding, and you don't get a flat line. You get a U. Accuracy peaks at the very start, which they call a primacy bias. It peaks again at the very end, a recency bias. In between it sags. The paper points at the cousin of this in psychology, the serial position effect, which is why you can recite the first and last items on a shopping list and lose the ones in the middle. Their most deflating experiment was a plain comparison. They ran GPT-3.5 Turbo, which tops out at 4,000 tokens, against the 16,000 token version of the same model, and the two curves came out, in their words, nearly superimposed. 4 times the room. Almost no change in how well the room got used. That paper landed in the middle of an arms race. GPT-4 arrived in March 2023 with an 8,000 token window and a 32,000 token variant in the API. GPT-4 Turbo brought 128,000 that November. Google announced Gemini 1.5 Pro in February 2024, shipping at 128,000, with a million token version in private preview for a limited group, and, it said, research tests that had reached 10 million. Meta's Llama 4 Scout claimed 10 million on the day it shipped in April 2025, in a post that also said the model had been trained at 256,000. Every one of those launches needed a headline number, and there was a convenient test standing by to supply one. The test was Needle in a Haystack, built by an engineer named Greg Camrat in November 2023. You bury one odd sentence in a wall of unrelated text, vary how deep you bury it, and ask the model to fish it back out. Models got extremely good at that. Then NVIDIA researchers built the version with the loopholes shut. A benchmark called Ruler, first posted in April 2024, adding several needles at once plus multi-hop tracing and aggregation across the whole input. 17 long context models went through 13 tasks. Their conclusion in the paper's own sentence. While these models all claim context sizes of 32,000 tokens or greater, only half of them can maintain satisfactory performance at the length of 32,000. A second team went after a subtler cheat. Ali Madaresi and colleagues noticed that in the standard test, the needle usually shares literal words with the question, so a model can locate it by surface matching without understanding a thing. Their benchmark, NoLiMa, strips that overlap out. Presented at the Machine Learning Conference, ICML, in 2025, it tested 13 models advertising 128,000 tokens or more. At 32,000, 11 of them had dropped below half of their own short context baseline. GPT-4o fell from 99.3% to 69.7%. In July 2025, the database company Chroma ran 18 models through a related battery and published the results under a name that has since crossed into vendor documentation: context rot. Anthropic's own page on context windows now warns, in its first few lines, that more context isn't automatically better. So what actually works? 3 things, and a larger buffer isn't any of them. First is retrieval, and the paper the industry builds on came out in May 2020, when Patrick Lewis and 11 co-authors described retrieval-augmented generation. Their framing was to pair the model's parametric memory, the knowledge baked into its weights, with a non-parametric memory, a searchable index sitting outside it. Take the question, fetch the handful of passages that bear on it, put only those in the window. The window stays small. The middle stays short. You never build the haystack, so nothing has to be found in one. Second is summarization, which the field now calls compaction. As a conversation nears the limit, the system writes a summary of the older stretch and restarts the window with that summary standing in for the transcript. Anthropic ships this server-side and describes the bargain in its own docs without dressing it up. As a conversation grows, response quality degrades, so compaction replaces older content with a concise summary. Detail is always lost in the swap. The wager is that a decent summary costs you less than a rotting window would. Third is memory built as an explicit system, and the cleanest early statement of it came in October 2023 from Charles Packer and 6 co-authors at Berkeley in a paper titled MemGPT, Towards LLMs as Operating Systems. Their move was to steal from operating systems, which solved a version of this problem long before any of this existed. An OS gives you the appearance of vast memory by shuttling data between fast memory and slow storage. Run the same trick here. Keep the context small and quick, keep the rest in files, let the model pull a file in when the task calls for it. That design is now a shipping product. Anthropic's memory tool lets a model create, read, edit, and delete files in a directory that survives between sessions, and the model itself decides what's worth writing down. And buried in that product is a line I'd frame. When the memory tool is switched on, the API adds an instruction to the model system prompt automatically, and part of it reads, "Assume interruption." Your context window might be reset at any moment, so you risk losing any progress that is not recorded in your memory directory. That's the architecture, stated flatly by the people who built it. The thing on the other end of your conversation is a mind that expects to be wiped, leaving notes for a successor it will never meet. When your assistant greets you by name, no recollection is happening. A program outside the model opened a file and pasted the contents into the top of a window that was empty a second earlier. Which hands you a few moves that hold up. Put the instruction you actually care about at the very start or the very end of what you send, because those are the two seats the U-curve favors. When a long thread starts drifting, open a new one, since the drifting is the mechanism rather than a mood. Restate a constraint instead of pointing back at message 4, because pointing back costs the model a search and restating costs it almost nothing. And read a headline context, number the way you read the top speed printed on a car. Real, measured, and nowhere near where you'll be driving. For 3 years, the industry tried to cure forgetting by building a bigger room. What finally helped was handing the machine a notebook and telling it, in the system prompt, that it won't be around to read what it writes.